Welcome back. We're going to be doing a new section today of sequences and series. In fact, we're going to be diving into the series part. So just a quick recap, what we've done so far, we've talked about sequences, and those are just patterns of numbers. And we've talked about three different types. I'm hoping you can remember what they are. Arithmetic, where we add a fixed amount to get from one term to the next. Geometric, where we multiply by a fixed amount to get from one term to the next. And quadratic. Quadratic are ones where we have a common second difference. Now we're going to talk about adding terms up. So we're going to dive straight into our workbook. Okay, I think we're on page 25. Yep. Okay, we're making good progress. And just a reminder that the videos aren't necessarily one video per lesson. If you finish the video and there's still time left in the lesson, start the next video. Right, here we've got a sequence, and I'm hoping you're all comfortable with what type of sequence that one is. That one is definitely arithmetic. Doesn't really matter, but if we add up the terms, then we have what we call a arithmetic, well, we have a series. Okay, this one would be an arithmetic series. Okay, all right. Remember we use Tn to represent the term. Well, not surprisingly, we use Sn to represent the sum. So for example, in this one, S4, the sum of four terms, 7, 15, 26. S4 would be 26. It's the sum of the first four terms. Now, we need to be able to calculate the sum for arithmetic series and for geometric series. We don't need to be able to work out the sum of a quadratic series. Okay, what we're going to do is we're going to derive a formula for Sn for an arithmetic series. But I'm going to introduce you to this by telling you a story about a little boy, and history doesn't really tell us exactly how old he was, but some people say he might have been as young as 6 or 7, and he was with his father and his uncle, and they were in a tavern, a shebeen, or a pub. This was actually in Germany, all right? And you might ask, well, what was a 6-year-old boy doing in a tavern or a pub or a shebeen? Okay, but I don't know the answer to that. But what I will tell you is that the father and the uncle were trying to add up all the numbers on the dartboard from 1 to 20. 1 plus 2 plus 3 plus 4. And they had a little competition to see who could get there first. And while they were still busy trying to work it out, Carl, the little boy, Carl Gauss, said, oh no, it's easy. It's 210. And they said, tula. But when they worked it out, they got 210. And they were absolutely amazed. They asked him, how did you get it? Because he didn't write anything down. What he said is, he said, I pictured all these numbers, 1 plus 2 plus 3, the whole way up to 20. And then he said, underneath in my head, I pictured those numbers going the other way. 20 plus 19 plus 18 plus down to 1. And then he said, when I thought about adding them, if I added these two rows, notice here I get 21. 2 and 19 is 21. 3 and 18 is 21. Okay, and 20 and 1 is 21. And he said, now I've got 20 lots of 21. All right, 20 lots of 21. Okay, 20 lots of 21. But that is not going to be the answer, because we're adding the green ones and the blue ones. So this needs to be halved, because we're adding the ones forwards and the ones backwards. So 20 times 21, he said, let's take 20 times 21 and let's halve it. All right, now it's easier to actually divide this by 2 and this by 2. So we get 210. And that's how he got the answer. Now that's an extraordinary story, because he did that. They say maybe he was 6 or 7, maybe 8, I don't know. And he did it in his head. He didn't use any pen, any paper, any calculator. And it's his idea that actually helps us create a formula for arithmetic series. Okay, we're going to look, because this will always work. All right, we're always going to get equal sums. You notice here we got the same answer for each of these additions. When we added down, we got the same answer. This will always work for arithmetic sequences. Why? Okay, and the reason being is that the top row grows by the same amount as the bottom row drops. Okay, and we're going to just show you with a little example here. Suppose we wanted to add 2 and 5 and 8, 11. Now you might say, well, we can just do that in our heads, and you're right. But if we write them down, 2 plus 5 plus 8 plus 11. Okay, those were actually the answers. Those were actually the terms on this first page. We actually know the answer is 26. But let's look at how we could use Gauss's method. Carl Gauss, okay? So there they are. Underneath, he thought about them going backwards. 11, 8, 5, and 2. And then he said, let's add, and here we get 13. Here we get 13. Here we get 13. And here we get 13. Now, the reason we get the same number each time is because this one, this one's starting here. When we go from here to here, we get 13. This grows by 3. Quadrat, this one drops by 3. So we'll get the same answer. Does it make sense? It always makes sense. Okay, right. Now, let's take a look. How many lots of 13 have we got? We've got 4 lots of 13. Quadrat, that answer of 4 lots of 13, 52, that's not the final answer. That's the blue ones, the green ones, and the blue ones added together. So our answer, we need to divide by 2. And we get a final answer of 26. And 26 is what we worked out on page 25. Okay, right. Now, this guy, Carl Gauss, he lived in Germany from about 1777 to 1855. And he was called the Prince of Mathematicians. Okay, he was exceptionally clever, and he did loads of clever things as an adult. He's one of the most famous mathematicians who's ever lived. Now, what we're going to do is we are going to use his method, and you need to know this for exams. We're going to use his method to create a formula for Sn. Sn being the number, the sum of the first n terms of an arithmetic sequence. Now, the very first term is a. We know that. For an arithmetic sequence, the next term is a plus d. The next one, a plus 2d. Wada, right through the nth term, and you'll remember this from our formula, a plus n minus 1 lots of d. Okay, that is the nth term. So that's Sn is the sum of n terms. It's the sum of term 1 plus term 2 right up to term n. Underneath, we're going to write them backwards, just like Carl Friedrich Gauss did. So this is still Sn, but now this one is going to be the last one here, a plus n minus 1 lots of d. That's the last term. And then the second last term, and wada. Down to a. I've just written them down the other way around. Now we're going to add these 2 rows. On this side, we get Sn plus Sn, we get 2 lots of Sn. Now here, this is going to be a plus n minus 1d. It's going to be 2a plus n minus 1 lots of d. But this is also going to be 2a plus n minus 1 lots of d. All of them are going to be 2a plus n minus 1 lots of d. That's that sum. That's that sum. All right. Now, altogether, they're going to be n. All right. They're going to be n. So instead of adding and adding and adding, 2Sn will be n lots of 2a plus n minus 1 lots of d. That's 2Sn. So if we divide both sides by 2, we get Sn as n over 2. 2 lots of A plus n minus 1 lots of D. And that formula we need to know. We need to know it for tests and exams. It does get given to us on the formula sheet, but we're going to use it quite a lot and we're going to see how it works. What it does is it allows us to work out the sum of some terms if we know A, we know D, and we know how many terms we want to add. Okay, now you might also see that there's another version of the formula, because if instead of 2a inside the bracket here we split this to a plus n minus 1d, this piece here is just our formula for Tn. So another version of the formula, which we do not get provided, is that if we know the first term and the last term, then we can just add those two together and multiply by the number of terms divided by 2. Okay, you don't have to know this formula. It can be useful. Let's pendula ikasi, turn over, and let's now use our new formula to try these sums. We'll do the first one together. In fact, we'll ask you to do the first one. I'm going to write down the formula for you here. Sn, just to remind you, Sn is n over 2, 2 lots of A, plus n minus 1 lots of D. Pause the video quickly. In this sequence, you should be comfortable working out what A and D are. And what we are wanting is we want S30, the sum of 30 terms. Okay, pause it, have a go and see. Okay, let's take a look. So, the sum of 30 terms is going to be 30 over 2. Sorry, guys. Okay, so the sum of 30 terms is going to be 30 over 2. 2 lots of A. A is 3, so it'll be 2 lots of 3. Plus 29 lots of D. Common difference here is 4. Okay, we'll try and see how much of this we can do in our heads. That's just 15. This is 6. And 29 times 4, I think, is 116. I hope I'm right about that, but I think I am. All right, and we are going to need to bring up a calculator. Okay, so there we have it. We've got 15, open brackets, 6 plus 116. Okay, and what that comes to is 1830. Right, 1830 is the sum of the first 30 terms. Okay, what we're going to quickly do here, we're just going to quickly check that, because remember it was 3, then 7, then 11, and you'll remember Microsoft Excel actually does arithmetic sequences very nicely. We can just drag that down, and we're going to drag it down to 30 terms, right? Now what you may or may not be able to read, and I suspect you probably won't be able to read, but over here, at the bottom of the screen there, it actually tells us the sum, 1830. But just to kind of convince you of that, what I'm going to do is I'm going to write a little formula in here, and I'm going to say, work out the sum of all the numbers in column A, okay, and there's the answer. It's 1830. Okay, let's dive back into looking at our workbook, and we've got there it is. Okay, now this question asks, how many terms must be taken to make a sum of 345? Well, what we need to use our formula. 2 lots of A plus n minus 1 lots of D. What variable are we looking for here? We actually are told the answer. We are told that the answer is 345. Do we know A? Yes. Do we know D? Yes. What we don't know is N. How many terms? So let's fill in what we know. We get 345. We get N over 2. 2 lots of A. Now 2 lots of A, I hope you're okay with me just going 2 lots of 2 is 4. N minus 1. And we know that D, all right, is 3. I'm going to write that 3 at the front there. Okay, now we've got an equation. It's actually only got one variable in. What we need to remember when we're solving equations is the whole idea of a balance, all right? We want to make sure that this thing remains balanced. So whatever we do to one side, we must do to the other side. Let's multiply both sides by 2. The reason I'm going to multiply both sides by 2 is because this side's being divided by 2. That will give me 690. Over here, I'm going to get, inside the bracket, I've got n outside. Inside the bracket, I've got 4 plus 3n minus 3. So I've actually got 4 and a minus 3. I've got 1 and I've got 3n. I've actually got that. Okay, what I've got actually is a quadratic equation. I've got 3n squared plus n, and then I'm going to minus 690. Okay, and we're going to now try and solve this. Remember, we could use our quadratic formula. I am expecting a whole number answer for n, so I'm actually going to try and see if we can factorize it. Okay, let's just think about some factors of 690. Right, and I'm wondering about maybe, yeah, let's just think. Okay, and in fact, if we go n minus 15 and 3n plus 44, right, we'll see that this actually comes out right, okay? I did use the quadratic formula off to the side, and I hope that you guys are okay with using the quadratic formula, right? But we get an answer now of n equals 15. So 15 terms is how many we would need to add up to make a sum of 345. Right, we're going to ask you to pause the video and try the next 2 questions, 40 and 41. Both involve the use of the same formula, and then once you've tried those, let it run again and see how we go. In fact, I'm looking at the length of the video. We're actually going to stop there, try them, and then we'll answer them in the next video. Okay.